Agricultural and Food Sciences, our special presentation for this afternoon. We're thrilled that you can join us, and we hope that this evening's this afternoon will be entertaining and as well as informative. My name's Martin Scanlon. I'm the Dean of the Faculty of Agricultural and Food Sciences, and I'd like to acknowledge first that even though we are coming here virtually today, I'd like to acknowledge that the University of Manitoba campuses are located on the original lands of the Anishinaabe, Cree, Ojibwe, Dakota, and Dene peoples, and on the homeland of the Métis Nation. We respect the treaties that were made on these territories. We acknowledge the harms and mistakes of the past, and we dedicate ourselves to moving forward in partnership with Indigenous communities in a spirit of reconciliation and of collaboration. We may not know each other today, but we're certainly not strangers. All of us today have some connection to the U of M, either as alumni or current students, as friends, as academics or staff, but all of us as members of the agricultural, food, and nutrition sciences community. Before we go on to the main part of the presentation this afternoon, the presentations from the graduate students and from Dr. Duncan, I'd like to share with you a brief outline on how the faculty in the university have been responding and indeed adapting to some of the profound changes that we've all been experiencing throughout this year. In mid-March, our campus effectively shut down its in-person operations, and we quickly shifted over to online teaching, and this was to ensure that our students could conclude the winter term successfully and also safely. The graduating class of spring 2020 had the unusual honor of being the first class to attend their convocation through an online ceremony. Simultaneously, while we were teaching and finishing off teaching, we had to adapt our research programs to the new reality of this pandemic environment. This required us to minimize the risk to our students, staff, and academic members, but we also had to devise fieldwork protocols that minimize the risk to members of external communities with whom our researchers and graduate students interact with. In most cases, the researchers and the teams worked remotely, doing work on literature or writing up papers. But after a period of careful planning, we were able to gradually return to physically distanced field work and lab activities, and that gradually progressed as the summer went on. As we approached the fall term, we built on our spring experiences and moved most of our academic instruction to online performance and to online platforms. By using live and recorded methods of class delivery, our instructors are ensuring that students have ready access to class presentations and notes, even if their internet connections aren't the best that they should be. I would particularly like to thank our faculty and our staff for adapting well to a very different mode of inspiring our students in their academic and their research that they're doing. I'd also like to thank the Faculty Student Council. They've alerted us to some concerns that they've had because of this remote learning mode, or they've suggested better ways of doing things. And they've also partnered with the faculty to establish a COVID-19 bursary fund to assist students who may not have access to all of their technology requirements to do their learning in an online mode. So even as we work towards a return to face-to-face interactions, I'm pretty sure that the transitions and adaptations that we made in education, in research, and in outreach will continue to have a profound and positive impact on how we deliver our faculty's mission going into the future. And indeed, we are having an impact, and I'll just give a couple of highlights in this. Just recently, Dr. Mario Tenuta from the Department of Soil Science was named the Natural Sciences and Engineering Research Council of Canada Industrial Research Chair in 4R Nutrient Stewardship. So a chair and the research that is firmly focused on the sustainability of agriculture for the long term. Another name you may recognize is plant scientist Dr. Martinez. He, along with his colleagues, were the only Canadian team named as a top 10 finalist for the Rockefeller Foundation Food System Vision Prize. And I can say that there were over 1,300 applicants from all over the globe competing for one of those top 10 spots. Our academic programs have continued to evolve and adapt, with both our diploma and our degree curricula recently undergoing renewal after extensive consultations with alumni, with industry, and also with community stakeholders. And I should say that the degree program did kick off just a couple of weeks ago and is already being well received by our students. In addition to equipping our graduates with the knowledge and skills to address future challenges, these renewed curricula in the diploma and the degree program continue to meet the professional accreditation requirements of organizations such as Agrologists Manitoba and the Institute of Food Technologists, as well as the Registered Dietitians of Manitoba and Canada. Our third pillar is outreach, and we continue to share our expertise in a variety of ways to a wide range of audiences. And part of that is the initiative that we're undertaking today. So whether it's extension to producers, community outreach program, or school engagement through the Bruce D. Campbell Farm and Food Discovery Center, I can confidently assure you that COVID has not stopped our mission of sharing our expertise with the people who can use it. As this afternoon's presentations will demonstrate, there are many ways of knowing, learning, and sharing knowledge. So right now, I'd like to call on Crystal Jorgensen, the faculty's administration communication specialist, to provide some guidance to you on how you, the audience, can participate in today's presentation.
Thank you, Martin. Right now, I'd like to let you know about the chat function for today's session. So as you're listening to the speakers, I invite you to visit the website that you see on the screen, www.sil.do, Slido, and it will prompt you to enter a event code. Our event code today is #FAFS, and that's Faculty of Agricultural and Food Sciences, FAFS. It opens up a window where you can enter your comment or question. It is a 160 character limit, so we invite you to be succinct in your questions. And also if you're directing the question to a particular speaker, we invite you to indicate that as well. And as we go along at the end, we will be bringing all the speakers back for the question and answer period, and I'll be reading out some of those questions.
Okay, thanks, Crystal. So in today's program, we're going to hear later on from Dr. Rob Duncan. Rob is an internationally recognized plant scientist who specializes in crop breeding. But first, we'll hear from two of our student researchers who are tackling some unique challenges. The 3-minute thesis competition is an academic competition for graduate students where participants have to present their research and its wider impact in 3 minutes or less to a panel of non-specialist judges. I can assure you this is a tall order. The competitions quickly become an annual highlight at the University of Manitoba, as it gives us a chance to hear firsthand about some of the groundbreaking research that our graduate students do from all over the campus. As many of you are probably aware, graduate students are the real primary workforce of our university's research engine. And as they team up with the sharp minds of our faculty members, they find new ways to push the boundaries of their field. They also power our knowledge economy, because many of them have spin-offs, such as patents, and they also find new ways of enhancing the vibrancy of our culture. So today's student presenters from the Faculty of Agriculture and Food Sciences were both finalists in the University of Manitoba's 2020 3-minute thesis competition. and they're going to share their 3-minute thesis presentation with us again today. Just as a reminder, our presenters will respond to any questions you might have about what they're saying today at the end of the 3 presentations. So keep the questions running through the chat. Crystal's going to monitor, and she'll pose them to each of the presenters. So first up, we have Jessica Nicksy. Jessica is a graduate student in the Department of Soil Science. So welcome, Jessica.
Thanks so much, Dean Scanlon. Have you ever thought about how nutrients cycle, or more often don't cycle, through our food system? For example, when you flush the toilet or throw an apple core in the garbage, where did those nutrients come from and where are they going? In the case of phosphorus, which is generally the second most limiting nutrient in cropping systems, the answer is very often that it came from a mine. But we don't have an endless supply of mineable phosphorus. Estimates are that we could run out in as little as 70 years. And where are those nutrients going? With the depletion of phosphate rock reserves looming, you'd think that we'd do a better job of capturing and reusing food and human waste within the food system, but we don't. In Winnipeg, our food and human wastes often end up in the landfill, where they contribute to methane greenhouse gas emissions, or in our waterways, where excess nutrients can cause toxic algal blooms. This is the linear food system: mine it, use it, and lose it. Of course, there is an alternative. We can stop thinking of nutrients moving through cities as wastes and start thinking of them as valuable resources to grow more food. This is the circular food system, and it is the focus of my master's research. I'm calling products that cycle nutrients from cities back onto farms anthronutrients, recognizing their anthropogenic or human origin. Anthronutrients have an especially important role to play on organic farms, where options for nutrient import are limited. If an organic grower doesn't have a source of livestock manure nearby, they often have a hard time adding as much phosphorus back onto the soil as they remove when they harvest and export their crops. And this has led to widespread phosphorus deficiency on the prairies, on organic farms. So my research then evaluates the potential of 3 anthronutrient sources to supply phosphorus and improve yields in these organic systems. My anaerobic digestate is made from processing food waste in the absence of oxygen, producing both biogas for electricity generation and this nutrient-rich digestate product to apply to the field. Frass is the waste product of black soldier fly larvae that have been fed a diet of restaurant and grocery waste. The larvae themselves can re-enter the food system as livestock feed, while their waste product becomes valuable fertilizer. Finally, struvite is a mineral fertilizer that can be precipitated from municipal wastewater, pulling phosphorus out before it can enter and pollute water bodies, and instead getting it back onto those farms where it's a vital nutrient. My research has looked at wheat and alfalfa in the fields and ryegrass in the greenhouse. We've seen all 3 of these anthronutrient sources outperforming the unfertilized control in alfalfa and ryegrass, and the frass has actually been keeping pace with our conventional comparison fertilizer, monoammonium phosphate, in every experiment. This research supports the value of these anthronutrients as sustainable phosphorus sources, which offer additional options for organic farmers and may even come to replace mined fertilizer. The message that I want to leave everyone with today is that in a truly sustainable food system, the waste product of one process becomes the valuable input to another. And this is the crucial role that anthronutrients will play in the future of food. Thank you.
Great. Thanks very much, Jessica. Some very interesting research that you're doing.
Thanks.
Our next presenter is Zoe Lee. Zoe is a graduate student in the Department of Food and Human Nutritional Sciences, and she's going to present her 3-minute thesis presentation to us. Welcome, Zoe.
Hi, everyone. I'm Zoe Lee. I'm the master student from Food Science and supervised by Dr. Felice Coxell. My master project focused on producing a healthy puffed snacks using extrusion cooking technology. The puffed snacks currently available on the market, like Cheetos, are all made from refined cereal flours, for example, cornstarch, which is high fat, high carbohydrate, low protein, and low dietary fiber. In one word, nutritious less. Incorporating nutritious ingredients into the formula is one of the biggest challenges that the snack industry is facing, because these healthy ingredients generally impair the physical quality of the products. It will make your puffs less crispy, much harder, less uniform, and maybe even ugly. But as a food science student and a snack lover, I aimed to produce a nutritious puffed snack with consumer acceptable physical quality. To do that, I chose the blends of barley and green lentil flours as my ingredients, not only because barley is high in dietary fiber and green lentil is high in protein, but also because they belong to different families of the crops, which means that they complement each other in many aspects, and their blends can provide consumers more comprehensive and balanced nutrition. Then I modified the whole process, including the blending ratio, processing moisture, and processing temperature. Here you can see what I got compared with one commercial product. Yes, my product is slightly harder than the commercial one, but it has a very good crispness value, which is the key that makes puffed snacks so attractive to consumers. More importantly, the protein content of my product is 12% higher than the commercial one, and the dietary fiber content is 6% higher. I also tested the protein digestibility and amino acid composition of the products. They all showed promising results. And that is exactly what I want to see and consumers want to see. Nutritious and delicious finally can be used to describe a puffed snack at the same time. And I hope we can all satisfy our late night craving without feeling guilty in the near future with this product. Thank you.
Okay, thank you very much, Zoe, for that interesting look at the nutritional and the food side of the faculty. So as you can see, the faculty spans all the way from the environmental side through to the health side of society through its connection through food and human nutritional sciences. Our next speaker covers some of the middle ground in the traditional agricultural side of things, in the plant breeding side of things, and so also associated with the agronomy. So I'm very pleased to introduce Dr. Robert Duncan. Rob is a current researcher at the University of Manitoba who's focusing on various aspects of breeding canola and rapeseed. Rob is a two-time alumnus of the University of Manitoba and has been a faculty member in the Department of Plant Science for the past 8 years. So welcome, Rob. Looking forward to hearing what you have to tell us about canola breeding and its relevance to society today.
Thank you very much, Dean Scanlon. Pleasure to be here, and look forward to spending the next few minutes with you, just telling you about what we've recently been working on and are currently working on in the canola and rapeseed breeding program at the University of Manitoba. I came back to the university in 2012, as Dean Scanlon said, and I say came back because I completed my bachelor's and master's early in the 2000s at the U of M. And following that, I went to the University of California, Davis for my PhD. I must say, and the little story that I wanted to tell you as an alum of the University of Manitoba is I was this farm kid growing up from Miami, Manitoba, going off to the University of California. And I must say I was worried whether I was going to be prepared and how I was going to do in that setting. But in only a few weeks, I really learned how good the quality of my education was at the University of Manitoba, how well prepared I was to excel at one of the top agricultural universities in the world. And for those reasons, when the opportunity opened up to come back to the University of Manitoba in 2012, I jumped at it to come back to this quality institution and lead this internationally recognized breeding program. So before I can't start off this talk without talking about the people that came before me in this plant breeding program. And of course, you'll all know Dr. Balder Stephenson. And the tremendous impact he had, and his development of the first registered canola cultivar, Tower, in 1974. But there was many world firsts for the University of Manitoba and his breeding program following that too. In 1982, the University of Manitoba and Dr. Stephenson released the world's first hyaluronic acid rapeseed cultivar, or HERE cultivar, which I'll talk more about in a few moments. And in 1987, Dr. Stephenson and Dr. Scarth released the world's first high oleic acid cultivar, which really opened the door for specialty oil canolas. And then in the 80s, two other world-renowned scientists came in, Dr. Peter McVetti and Dr. Rachel Scarth, to take over the canola and rapeseed breeding program. And they had many firsts throughout the 80s, 90s, and 2000s. And so it was a true pleasure and honor to come back to the program and try to build upon the successes that they've made since the 50s. So to bring you up to the current time point, these are some recent students over the last number of years. And these students and staff are really the ones that make the breeding happen here. I can't go any further without thanking them. They are what I like to call the trait developers. They're working on different traits, whether that's seed quality, whether that's agronomic performance, whether that's how the crop stands, where it's lodging resistance. They're working on a wide range of traits, and these traits, they're looking at some of the genetics and the mechanisms that control the traits that ultimately can funnel into our commercial breeding program at the University of Manitoba or benefit the entire canola industry. And so I'm going to tell you about some of the research that they've been working on. But I can't go any further without highlighting the staff that within the breeding program that also make everything happen. This was our field crew this past May, right after we got back onto campus, and around the 24th of April, I believe it was. We were all set to go, ready to go seeding, and it was a cool, wet spring, and we had to, or a cool spring for sure, and we had to hold off until about the 10th of May before we could get seeding. But you can see some of the masks we already had in place at this time, and I must say, because of the staff and students in the breeding program and at the University of Manitoba, we were able to make 2020 an extremely successful field season under these different circumstances. So I didn't want to go any further without recognizing them. I'd also like to thank NSERC, who is one of our main funding partners, along with our industry partners in Nutrien and Bunge, for making much of this research possible, as well as the tremendous support from the University of Manitoba over the past many decades to be able to continue this research. So I wanted to start off just with showing you the progress that we've made really since 2012. And so what we have here on the left is our last open pollinated cultivar, Red River 1861. And so hybrids really came into the canola industry in the early 2000s and really took off then. We didn't have our first hybrid in our small hyaluronic acid rapeseed breeding program until until about 2013. And that was deemed high HERE 1. And so what I just want to show you is from our last open pollinated cultivar, Red River 1861, show you the progress over some of the hybrids that we've had. In 2015, we released high HERE 3. In 2017, we released Evolve, which was a world first with a pollination control system and herbicide tolerance in hyaluronic acid rapeseed. And just as of data that we've received late last week, some of our new hybrids are doing well over 20% better than Red River 1861. And so we're excited to continue to trial those in a wide range of Western Canada and across multiple years. So I want to point out at this point that a lot of the research that the students and that the staff are focusing on is in hyaluronic acid rapeseed, so not necessarily canola quality. So just to define hyaluronic acid rapeseed, or HERE, is it has a erucic acid component over 50% in comparison to canola quality, which is less than 2%. HERE also has low glucosinolate content, just like canola does. So a lot of our commercial development of hybrids that we release and farmers grow in Western Canada is in that here market class. However, all the traits that the students work on could be applicable to the canola industry across Western Canada as well, because we are talking about the same species, Brassica napus. This is a snapshot of some of the students and our postdocs that work in the program, and I just wanted to highlight some of those traits, and as I mentioned before, those trait developers and things that they're working on. Ashley on the left is a master's student, and she's working on protein quality. So we are working on numerous aspects within protein-related traits within canola and rapeseed, and that includes protein quantity and numerous aspects of protein quality, and that includes the seed storage protein type, the amount of those seed storage proteins, and the amino acid contents. And what we're finding is that there's quite a bit of variation in the protein quality, and we can really make progress in the coming years for some of those traits. We have students also working on lodging resistance, shattering resistance, abiotic stress, so excess moisture and drought tolerance, as well as a lot of biotic stress, mainly in terms of disease resistance, such as blackleg resistance and clubroot resistance. So that's what a lot of our student projects are working on within the program. And again, interesting findings that they find in their master's and PhD can go to benefit the entire canola industry. One of the main strengths of the University of Manitoba was its germplasm collection, both in rapeseed quality and canola quality, and that goes all the way back to Dr. Stephenson, in addition to all the other Brassica species. And so you cannot have a successful plant breeding program in any crop without that diversity and that variation for these traits to work with. And that's why we're finding some of this variation for protein quality and protein quantity. But I must say it was very enticing to come back to the program because of this, because of that germplasm collection, but because of the excellent field resources that we have in terms of multiple research stations around Manitoba, the excellent equipment that we have to work in the field, the facilities such as our molecular labs, our seed quality labs, as well as our greenhouse facilities. And we're constantly making improvements to all those facilities to keep up with the industry. And so I must say the support from the University of Manitoba and our industry partners and NSERC to make all this happen has been absolutely critical. Wanted to give you a quick idea of what one of those research locations would look like. This is our Carmen Research Station, or one block at the Ian N. Morrison Research Station in Carmen. So this would be some of our here breeding trials. In here we would have multiple replicated trials, and we're comparing some of our new experimental hybrids against some of the industry checks, trying to pick out those improved cultivars. And what's so challenging about this is often we're doing it for 15 plus traits. It's not just yield, even though of course that's important, but we have to combine yield with all those other traits, many of which I've listed before. And that's what makes plant breeding so challenging yet so exciting. This just gives you an idea of the research locations that we'd have across Western Canada. So we're truly a Western Canadian breeding program. My team that you saw in those pictures, we work in and manage most of the locations within Manitoba. However, we work with our industry partners, mainly Nutrien, in terms of handling the sites in Saskatchewan and Alberta. And I have the pleasure to be able to go to these sites, rate them, and select the varieties, and then gain all the yield data, the agronomic data, and seed quality data from all these locations. Hopefully finding that variety that stands out all across Western Canada, and we can register with CFIA and make available to the farmers in Western Canada. So the advantage of a breeding program like this in a public institution is that our students get to have the experience of working on their academic projects or their basic genetic products, but being exposed to a commercially viable and successful plant breeding program. And so this picture here is just one of those steps. Here in a small 1 meter by 1 meter tent, we're making experimental hybrids, brand new, never seen before hybrids. And in a tent like this, we would have 3 rows. There's usually 3 to 5 plants per row. And in the middle row is the male, and the outside 2 rows would be the females. And those little black dots in the upper left corner of this front tent are flies that would do the pollination. And once the male has finished flowered, he would be pulled. And we would eventually, once the 2 outside rows were mature, we would harvest the seed off of those. And those are brand new hybrids that we could take to all those testing locations across Western Canada in the coming years, hopefully finding those that are most beneficial to our growers. I wanted to point out that we also, like much of the canola industry, have a big program in Chile. So this is an example of a tent that's much larger than 1 meter by 1 meter in Chile. And in here we can make multiple new hybrids, sometimes 12 to 15 brand new hybrids in a tent such as this. And what we're doing there is we're utilizing the Southern Hemisphere and really using time efficiently in terms of in our non-growing season in Western Canada, we're still able to produce brand new hybrids. We'll get the seed back in mid-March so that we can plant it here in early May. And it really expands our capabilities. This would be an example of one small site in Chile. In each of these little sections of this larger tent, we could be producing the males or females in pure seed production, or we could be producing hundreds of hybrids in a setting like this. So that's a really interesting and fun component of the project, conducting the research down there as well. And as I said, exposing the students to the entire process of a commercially viable and successful plant breeding program. Here's an example of our large-scale seed production in southern Alberta. You can see this strip going down the middle. That's the male bay, very similar to those 1 meter by 1 meter tents, surrounded by the female bays on the left and right. And just like in the tents, when that male is mature, we will cut that male out and harvest the hybrid seed that would go directly to the growers in Western Canada. So that's really good exposure for the students to be able to see this large-scale seed production within their graduate degrees. So that seed that would be produced in a field like this would then go out into a commercial setting. This is a picture of one of our newest varieties on a few hundred acres in Western Canada this past summer. And so when we're rating those locations all across Western Canada, we will tour and meet with many of our farmers that are growing our varieties, and it's so interesting to hear the good attributes about our cultivars and even the poor ones, because then we're able to take that feedback and factor it into our breeding methodology and our designs to improve our varieties even further. And I must say, as a plant breeder, there's nothing more rewarding than standing in a field like this and knowing that you've had a hand in developing that variety. So with that, I'd like to thank you for your time, and I welcome the questions coming up, and I'll turn it back to you, Dean Scanlon.
Thank you very much, Dr. Duncan. Thanks for that great overview of the work that you're doing, both on the research and the training component in canola and high russic acid rapeseed. So that's great. Thank you, Rob. We'll now check in with Crystal, who's monitoring the chat. But what I suggest is, just so people are not intimidated by the chat box, but to ask questions, please type in the city where you're from. And that way, then that'll give you some experience using the chat function. It also gives us an idea about what's the breadth of the audience that we're reaching to potentially across the globe, if not across Canada. So, Crystal, you're going to remind us how to share questions.
Yes. So as you'll note, just below your YouTube window, there's a little description box, and that's where you'll see the URL for the Slido chat app. So I encourage you to open a new window, or maybe just go on your phone and visit the www.sil.do, and it will ask you to enter an event code. You're going to enter the hashtag FAFS, and please drop in a question. Let us know who it's for, and just be cognizant that it's 160 characters, so just like a tweet, you need to be succinct. Yeah, and we'd like to hear from all of you. We'd like to hear questions for all of our speakers. We've had one person comment that they're joining us from Winnipeg, so I look forward to hearing from more people. As we go, I will give you a prompt, Martin, when we get some more questions. Maybe you could ask a couple of, oh, hang on, we've got a question. We've got a question. So we have a question coming in from Victoria Beach, Manitoba, and the question is directed to Jess. Jess, where did the digestate for your experiment originate?
So it's actually from Ontario, from a company that collects food processing waste. I think a lot of like industrial food waste, and then maybe some municipal food waste as well, because there's much better organics collections programs in Ontario by and large. And then they do that anaerobic digestion process, and then they're actually producing electricity right on site, and also producing this fertilizer to be used by farmers mostly in the area. We don't have on the prairies, as far as I know, any sort of like digestion of food waste at the moment, although the frass that I use, they actually have a facility in Calgary now, and there are some composting processes for food waste on the prairies. Not in Winnipeg yet, though. We're getting there, I think, slowly.
Awesome. Thanks, Jess. We have a question for Rob. It's coming from Alan in Miami. He asks, what's the acreage for here in Canada, and how is the oil used?
Thanks, Crystal and Alan. The here oil is used as a lubricant and a slip agent, so it's used in a lot of household products and plastics, from garbage bags to saran wrap, and it's a lubricant that allows you to pull things off the roll, and so that's what it's used in. The here acreage is small. Our industry partners do keep that confidential, I will say. It's a fraction of the canola acres, but it's been a really good opportunity for the University of Manitoba to be able to have that commercially viable breeding program and train students in that atmosphere, whereas in the larger canola world we would have difficulty competing with some of the larger companies just in that setting alone.
Awesome.
Okay, thanks, Krista. I saw your note. Jessica, I was just going to ask you a question. Are any of those products, are they commercially available, or they all are?
Yeah, all three of them are commercially available. I will note, actually, the struvite is not yet approved for organic production. In Canada, there's a review process going on. It's actually been suggested for approval in the European Union, and I think that their process might be a little bit ahead of ours. So it might be a little while. If there's any organic farmers watching, that's not actually something you can use on your organic farm yet, but the frass and the digestate both are commercially available. I know that the digestate is used on corn acreages in Ontario. The frass, I believe, is usually used more in market gardening production and maybe greenhouse production. So we were really doing some of the first research on this type of product on the field scale in the prairies.
Great, thank you.
Yeah, thanks for the question.
Awesome. Okay, and we have a few more people telling us where they're from. We have Winnipeg, Mississauga, Okotoks, Altona. So we've got some good cross-Canada coverage here. We have a couple of questions for Zoe. Zoe, are you planning to modify the hardness of your new product, or is it good enough to attract snack fans? And someone else asks, how will you address the high hardness of your snack? So they're sort of the same question.
Yes, I think the hardness is a problem. It's treatable because we have tried outside the lab, but I think we need to do some sensory tests to really evaluate how the customers to think. If it really affects the overall opinion, I think we will do some modification, like lowering the dietary fiber content or the protein content a little bit in the formula to achieve better sensory.
Awesome. Thank you.
Maybe I'll run a question
Sure.
by both Jessica and Zoe. So you're in quite different aspects of the food system. How did you both get into your particular area of research? Maybe start off with Jessica first.
Sure, yeah. So I actually ran a small organic market garden for a few years after I graduated from my undergrad degree, which was in engineering. I realized I really liked living things, and so I started working on farms. I ran a small farm, and then I realized that what I was so excited about was, like learning something new from these plants every day. And I got to a point where I didn't really like the aspect of running a business, but I loved growing things, and I loved trying to figure out the best and the most sustainable way to grow things. And I cold emailed Dr. Martin Entz, my supervisor, and he got back to me, and he was so enthusiastic. And I've been really, really lucky to find him and Dr. Brian Amiro, who's a co-supervisor for me. I've had just an amazing experience at the U of M, and been really lucky to get to study what I'm studying. Yeah.
It's a very interesting path. Zoe.
I think my answer is small comment, because I think plant protein is a very popular topic in Canada recently. So when I get to know my project will based on extrusion, I think it is a good opportunity to bring the plant protein into the snack, which is more close to our daily life, like everybody consumes snacks. So I think it is a good idea to focus on the protein and diet fiber. And I have a question for Dr. Duncan.
Go ahead.
Yes.
Yes, because from my impression, I think canola is mostly often used as the oil seeds. It's for the oil extraction, but you mentioned in your presentation that you are also looking into its protein quality. So I'm just curious, are you trying to making any products out from the canola, like canola protein isolate?
Yeah, no, we haven't been working on necessarily developing new products, but definitely developing new genotypes with increased protein or modified seed storage profiles or amino acid profiles. And so I think you're completely correct that there is a huge push for plant protein. And I was thinking as I was watching your talk, you're clearly going to be putting in a feedstock into your processes that is available. But I think what we're going to have available in the future in a wide range of crops will be varieties available, whether we're talking peas or canola or beans or soybeans, whatever the crop may be, with modified protein contents or protein qualities. And I think that's going to even further improve those protein levels that you have in some of your products.
Thank you.
Great. We have a few more questions that have come in. One important comment, someone commented, are we able to view this afterwards on YouTube? And the answer is yes, this is being recorded and it will be available, not immediately, but very shortly. We will be posting this up back into our YouTube channel. So that's a good question. This question is for Jess. Is there an estimated percentage of vital nutrients, NKP, that could be captured by a composting program in a city as large as Winnipeg?
I love this question. I spend a lot of time thinking about this. So I think what the question you're asking is for, in terms of all of the food that is imported into a city like Winnipeg, how much of the nutrients that are in that food would we actually be able to capture and get back onto farmland, rather than that, you never have a perfectly efficient system, so some of them will escape. I don't have actual values for you, but so my research focuses on phosphorus, which unlike nitrogen, I don't know how many agriculture alums are out there who had to take the soil fertility class with Don Flayton, and he described nitrogen as the sort of confusion corner of plant nutrients, because it can go so many places and you can lose it in so many ways. It's really dynamic. You can lose it through leaching, volatilization, and it can end up in a gaseous form. So you're never going to be able to capture all of the nitrogen nutrients. But so one of the reasons that I really like focusing on phosphorus is phosphorus doesn't really have any of that. It usually doesn't. It's not particularly water soluble. It doesn't leach away. So I actually think that you could capture most of the phosphorus coming into a city like Winnipeg if you had a good composting collection program. Also, if you have programs for collecting nutrients from municipal wastewater, which I think is really important. My advisor, Dr. Entz, describes Winnipeg as Manitoba's largest feedlot because we are animals. We have nutrients that move through us and come out of us. And if we let those all go, we will eventually run out of phosphorus. So I think potassium, I don't know that I could really speak to, but I think nitrogen, you're never going to be particularly efficient. Phosphorus, you can be quite efficient at capturing it and reusing it.
Manitoba's largest feedlot. I like that. That's a great one. We have a few more questions. Rob, you're getting a few here. I have noticed canola seems to be getting more resistant to salinity. Is that a direct or indirect selection parameter? That comes from David in Minto.
That's a good question, David. I think it could be one of both, direct or indirect. I would think just with the wide range of testing locations and registration criteria that most companies or groups, organizations that are releasing cultivars, I would think a lot of it just comes through in indirect methods. But there's no doubt methods both in a controlled environment and in the field where you could impose that stress upon it as well. And so that's interesting to hear. Some of that might just be coming from some of the hybrid vigor that we're getting out of the divergent hybrids. But I think a lot of it would be coming from those diverse areas where we're testing the crop during the registration process.
Thank you. I'm not sure who this one's directed at. What would be the rationale for regulatory agency prohibiting genetically modified organisms in organic products?
Jess, I can. Do you
that? Yeah. Maybe that's directed at me. Yeah, because I do research organic systems. I think it's a bit controversial. I think that people who buy organic products generally don't want genetically modified organisms in them is a big piece of what it comes down to.
Maybe if I can jump in, Jess, I do think, and I do have some experience on the organic side of things from other institutions, and even on our family's farm. But I really do see a fit that they shouldn't be opposing sides, and really there should be cases where transgenic crops, and I don't like the term genetically modified because pretty much any food that we eat has been modified by humans over thousands of years of selection. So I really do think that transgenic crops and improvements that we have through molecular biology should be synergistic with organic cropping systems.
Awesome. This one is for Rob. Are there agronomic traits of canola that are becoming more important, or that you see are becoming more important?
Yeah, great question. I mean, there's no doubt that shattering resistance has taken off and has a big market share, and rightfully so. I mean, we had these giant windstorms a couple of weeks ago, and it was amazing to see the canola that was still standing and how well it tolerated it. So that agronomic performance trait is critical, and I think it's going to continue to be critical. And then in addition to that, then if you've got that crop that you're going to let stand possibly into direct harvest, that lodging resistance is key, and that standability, so that you can come in and cut that mature crop and in one operation. Those are really critical. I think there's going to be more other traits come in as well in terms of agronomic performance. A lot of it coming down to possibly abiotic stress and nutrient utilization, I think, are going to be key moving forward as well. I think anything we can do to utilize the entire plant as efficiently as possible, and so I'm talking about the seed for the oil and for the meal, but also the plant material and stubble. I think improving the efficiency of the entire crop use is going to be key.
Good, thank you. This question is for Jess. What are your thoughts on the sustainability of animal agriculture, specifically in focus of the nutrients, of course?
Yeah, that's a really good question. I think the first point that I would make is that humans are animals. So I don't really, even if we moved to eating mostly plants, there's still animals in the system, and the animals in the system are us, and they're a really important component. So that's sort of from the nutrient cycling perspective. We're never going to get away from having both animals and plants in our agricultural systems because we are always going to be animals. I think you're probably talking about livestock and how sustainable livestock are. They actually are a really great mechanism for cycling nutrients on farms. I mentioned a lot of organic farms on the prairies have phosphorus deficiencies, and I would say the exception are generally the ones that have livestock around, because they actually, through grazing and manure applications, are recycling nutrients on the land rather than harvesting them and removing them generally. So I do think that animals play an important role in sustainable food systems. My sort of my bone to pick is that we often don't think of ourselves as animals in the food system, and I really do think that we need to do that more. So I hope I've answered the question.
Thanks, Jess. I have one more question off of our chat window here. I also have a check-in from another commenter, Dr. Gordon Hills, who is a BSA 69, MSc 71, PhD, PAG from Vermilion, Alberta. That's great. Nice to have you with us, Dr. Hills. Yeah. The question is coming from, not from Dr. Hills, but from Anonymous, or maybe it is coming from Dr. Hills. It's hard to tell on this chat. The question for Rob is, there are different canola oil profile products. What other oil profile will be worth looking into?
Excellent question. I think any profiles that from a nutritional standpoint, I think any modifications that we can make there are going to be very useful. Also, just the extraction efficiencies, anything we can do for the oil extraction to not denature or hurt the protein in the meal side of things, I think those are going to be key. But I think a lot of it's going to come down to the nutritional side of things, as well as shelf life and stability. But I think any improvements that will improve our nutritional capacity from the oil will continue to develop as time goes on.
Rob,
yes.
While we see if there's any more questions, we hear a lot about precision agriculture and digital agriculture. Does that play a role for you, sort of harvesting large amounts of data and data analytical techniques in your program?
Yeah, it's starting to. I must admit, I'm maybe a little behind, but this was the first year we flew all our locations, all those trials that I showed you with drones, to try to anywhere we can improve our efficiencies in rating and gain data quicker, and assessment on a lot of those agronomic traits and yield itself is going to be very useful. We're always in a major time crunch to get the data in late August, early September, so that we can make our selections and get our seed down to Chile on time. So anywhere we can use that technology to improve our selection decisions, decrease our costs, improve our efficiencies is going to be really critical for us. And for me, on a bigger picture as a plant breeder, one of the areas where I think and this would tie into Jess's research as well, where we're going to be able to make some of the biggest contributions to agriculture moving forward is hybrid or cultivar specific management. So rather than treating the 3 or 4 or 5 canola cultivars the same on our farm, either in planting date or the nutritional package that we put onto them, or herbicides or fungicides, treating each one individually, just like you and I would have different nutritional requirements. And so I think digital ag is going to play a big role in that, in managing those hybrids and cultivars specifically to that, to the needs of that individual genotype.
That sounds like a bold new frontier.
Mm-hmm.
Looking forward to seeing that. Good, Rob. Crystal?
Yeah, we've got a question for Zoe and then a question for the dean. The question for Zoe is, how about the costs? Would they be higher than regular Cheetos if your product gets commercialized?
I haven't. I thought about this question, but I haven't done the calculation because we bought the materials in the big batch. But I think it won't add a lot because we didn't do any modification from the materials, and we don't even have the coating. But if we think about the more flavors, we may add that. But I don't have any extra cost from that other than the regular processing. It is just the modification before the launching. So I don't think it will add a lot price to the real product.
And I would have to think people might pay more if they thought it was a high protein product. I think there's a demand for higher protein product. Dean Scanlon, what are your opinions on vertical farming? Do you think it will be the future of food production?
Yeah, I'll turn it over to Rob to sort of complement this. Realistically, I don't think it will be the future of farming. It will be a component of the future of farming, certainly where you've got wide open fields with abundant water supplies, good nutrients and sunshine. There's always going to be a part for that crop that's associated with wide open spaces. But if we look at some challenged communities, say remote communities with very little arable soil, then I think that vertical farms do have a part to play. Certainly you can look at cities such as London, New York, where unused spaces are actually fitted out with vertical farms. So it's definitely going to be a component of the future. But as a replacement, it's certainly not going to be a replacement in my lifetime. But as the technology keeps evolving, I'm sure it will play an increasing role in agriculture.
I think
Fantastic.
that summed it up well, Dean Scanlon.
We have one last question, and I think after this question, we'll maybe want to wrap up. We're getting close to our end time. The question's for Zoe. In the process of finding improvements to nutritional composition of existing snacks, do you ever find new flavors or even new types of snacks?
That's an interesting question, but I think for the highly nutritious snacks, I can find in the market now. They are most likely have the chocolate flavor, because I think we are using the nutritious ingredients like the lentils or the other pulses. They all have a strong flavor, like plant flavor, and we need to another strong consumer preferred flavor to cover the original plant flavor, which is chocolate in most of cases, or some other like peanuts, some other strong flavors. So it is possible to deliver to produce more flavors, but I haven't done any research about that at this moment. But it's a good thing to look at in the future.
Thank you so much. I think we're out of questions, Martin. So.
All right then. Well, and we're coming close to the top of the hour here. So I'd like to thank each of our presenters, Jessica, Zoe, and Rob, for today. I'd also like to thank Crystal for keeping the chat line open and for keeping the questions fed through to us. And I'd also like to thank a couple of people in the background, Chris and Teddy, who are part of the U of M's media relations. So they managed to keep this seminar out and live. So thank you, everyone. So the faculty will be continuing to offer online seminars throughout the year. So please watch out for updates on our website and our social media accounts. And if you don't already receive our bi-weekly newsletter, Aggie News, you can email us at agfoodsci, that's AGFOODSISCI @umanitoba.ca and sign up. So I've said it before, but it bears repeating again. This faculty, the Faculty of Agricultural and Food Science, is focused on one of Canada's most fundamental sectors, the provision of food. And the faculty covers the whole gamut of that food system with numerous disciplines which connect with this provision of food. And you've seen a snapshot of that today, going all the way from the environmental through to the human health side of things. One thing about this pandemic has shown us is that there is a real need, a critical need for a stable and safe food supply. And that's never been greater as we've come to realize through the pandemic. And so I'm very proud of the students, the faculty and the staff, the alumni, our partners, and all of the contributors that make the good things that we do in this faculty happen. So thank you to all of them. Thank you to all of you for tuning in, and I look forward to seeing you in virtual mode again as we prepare for our next seminar. So thank you, and good afternoon, everyone.